This SQL query is an absolute mess. I'll show you why it's bad and how we can improve it step by step. This is a query that gets information about students and their grades. It translates their grade numbers into a rating system from A to D. Why is this bad? You might be looking at this and thinking it looks okay. It's formatted, it has clear case statements, and it has table aliases. However, there are a few things. The case statements are quite repetitive. There are 10 grade values that are being checked, and each of them has different case statements. It's hard to maintain. If we had to change the grading logic, we would have to do it in at least 10 places. This is risky and hard to maintain. There's also a lot to understand in this query. The select clause is long and has a lot of logic. So how can we improve it? First, let's run the query so we can see the results. I've set up some sample data just so we can see a result here. We can see 24 rows here. We see some details of students, advisor details, course details, a bunch of letters for their grades, some values for their attendance, and other categories. What's the first step? We should format it. I'll make some adjustments to the format of this query so it's easier to read. This also makes it easier to edit. Now, with that cleaned up, what's next? We have a few tables being read here. A lot of these calculations in the case statement come from the enrolment table. One thing we can do is move some of these calculations to a separate part of the query within a common table expression. This means we have one area that defines these calculations, and then in the main query, all we do is select the calculated fields. This should make the query easier to understand. To do this, we'll use the with keyword to create a common table expression. I'll call it enrolment with grades. Inside this CTE, we can place all of the fields that come from the enrolments table. This means most of the case statements and some of the other fields like student ID and course ID. Next, we move the criteria from the where clause into the CTE because they refer to the enrolments table. Now in the main query, we change this enrolments table here to the enrolment with grades. We join based on the student ID. Our query is now ready. This change means that most of the calculated fields, those fields with the case statements, are all in a single place. We'll see how that can help a little later in the video. We run this query and see the results, which are the same as before the change. This is a bit better. What's next? The logic for calculating the scores here is quite repetitive. We have essentially the same calculation listed 10 times. We look up a score to see where it fits in a predetermined range and return a letter. One way we can simplify this is by moving the logic to a lookup table. This means that instead of having this case statement in the SQL query many times, we have the logic for the different scores and letters in a single table. This should simplify the query and make it easier to maintain. If the definitions change, we can update the data instead of the code. Let's try that. We start with create table. What comes after that? I'll just look on my little cheat sheet here. We have the name, then brackets. Back in my code, I'll add the name of score grades, then a pair of brackets. Inside the brackets, we can add our columns. First, we want the grade letter, which is the letter to return, such as A or B. Then we have two columns. We have the lower limit, which is the number that represents the lower of the range for a letter. Then we have the upper limit, which is the highest number in the range. We run this statement and our table is created. Now let's insert some data. To insert a record, we write insert into, table name, columns, then values. This SQL file here has a list of commonly used statements and commands, which helps me remember the syntax for things like foreign key constraints and alter table commands. You can get your copy at the link in the description. Back to our insert statement. Let's insert some values into this table. We'll insert a row that represents F, with a lower value of 0 and an upper value of 60. This means any value between 0 and 60 means an F. The next row is D and is between 60 and 70. If you're wondering why there are two values with 60 and if it will cause a problem, that's a good question. When we update the select query, we'll ensure we won't have any overlaps. We can keep going with this insert statement to ensure all rows are here. We run this and the rows are inserted. Let's update our main query. We'll do this for one grade first, then do the rest. First, we need to join to our new table. We'll join to the table here inside the CTE. This join is a little different to a normal join. We're matching a record where our score is between the lower and upper limits for the score grades table. So we do an inner join and match on the score greater than or equal to the lower limit and less than the upper limit. We join on two conditions like this. Also notice the operators here. I've deliberately used greater than or equal to here and a less than here instead of less than or equal to. This is so we avoid overlaps or issues if a score matches a limit value such as 60. I also didn't use the between keyword because this would perform an inclusive match on the limits as well and cause the same issue. Now that we have our joined table, we can display a letter. In the select clause here, we can select the grade letter from this joined table and give it an alias. It's already selected in the outer query or the main query, so that should be all we need to do. Now we can run the query and get the same results as earlier. We've updated our query, but we only did this for one of the scores. There are 10 score columns in our query. So in order to use this new table, we need to update our query to use it for each score. Let's do that. Unfortunately, to make this change, we need to join to the new score grades table separately for each score. This means we have 10 joins. We start by adding the inner join here. I'll copy this line here and paste it so we have 10 of the same rows. To make sure they are different, we'll give them a different table alias from S1 to S10. Next, we add the columns to the select clause. We'll get the grade letter from each of our joined tables. As we do this, we can remove the case statements. Our query is now ready. Let's run it. We run it and see our results here. So this has worked, but as we saw, we are joining to the same table 10 times. This isn't ideal. It would be great if the grade values were normalized. Instead of having 10 separate grade columns, we had a single grade table which had 10 rows for each student and enrollment. That way we would have only one join to this lookup table, making our query simpler. We can try to do this for our query. First, we'll create a new table to store these grades in a normalized way. We have an ID for the primary key. We have an enrollment ID, which is the foreign key to the enrollment table. We have the grade index number, which represents the number of the grade from 1 to 10. Finally, we have the score, which is the actual score value we want to use for our calculations. We run this and the table is created. Now we can insert some data. Rather than inserting the data manually, we can actually insert our data from the results of a select query. We can select each of the grades from our enrollment table using a series of union all keywords to combine the results into a single result set. This will mean the score values are loaded directly from the enrollment table into our new normalized table. We run this and the data is inserted. Let's update our main query. We update our inner joins here by removing all but one of the joins to the score grades table. Then we can join to our new enrollment grades table on the enrollment ID column. We can move up to the select clause and select both the grade index number and the grade letter from our new tables. This will show the index value of 1 to 10 in one column, then the associated letter in the next column. In the main query here, which selects from this CTE, we need to replace these 10 grade columns with our index number and our grade letter. This is a bit different to our earlier query, but our query is now ready. Let's run it. We run it and see a different result. We have 240 rows instead of 24. We also see a column for the index and a column for the grade letter. This is different because instead of one row for each enrollment with 10 grades, we have 10 rows for each enrollment. This may be better if you can work with it in the application, but there is a lot of duplicate data. Let's say this format is not appropriate to use because we need it in the original format. How can we use this grades table but get the data in the original format? We could look into using the cross-apply feature or maybe a pivot or unpivot. One way is to use a select query as a subquery inside the select clause. This subquery would select one of the grades from the related tables. Let's try that. We can open and close some brackets here in the select clause. Inside the brackets, we write a new select query. We select the grade letter from the score grades table. We select from the enrollments table, joining to the enrollment grades table and then joining to the score grades table. Once we have done those joins, we filter on records where the grade index is 1 because we only want to see the scores for the first grade, as this query is just for the first grade. We also want to filter this based on the enrollment ID matching the outer query, so we get the correct row. Then we give it a column alias. We can also remove the joins from the CTE as we don't need them here. In the main query, we select our grade 1 score value and we don't need that index value here. Our query is now ready, so let's run it. We see our results here. We have our 25 rows, which is correct. We also have our grade 1 score here, which comes from our new subquery. This has helped. However, we added this subquery here with a few joins and more code, and this is just for a single grade score. We would need to repeat this for all 10 grades, which would make the query arguably even messier. This grade lookup logic is a repeatable process. We give it an input and we get an output. This sounds an awful lot like a function in other programming languages. Fortunately, in many database vendors, we have the ability to create functions as well. This is a great use case for a function. We can have a simple function to calculate the grade letter from a score and call the function multiple times. Let's do that. The syntax here to create a function is specific to Postgres and will be slightly different in the other major vendors. However, the concepts are the same. We'll declare a new function called calculateGradeFromScore. I'll use this create or replace command, which allows us to rerun the command and replace the existing function instead of having to drop it. We'll provide an integer as a parameter and return a char value. We have this as $, which means everything after this is part of the function. We declare the grade letter variable. Inside this begin section, we have a select query which runs a case statement on the provided score value in the parameter. It calculates the grade letter and puts it into the variable using this into keyword. Then we return this grade letter variable. Then we end the function, add the $, to end the declaration of the function, and write the language name. Our function is now ready, so we can run this and our function is created. Let's see a couple of examples of how the function works. We can simply use the select statement and select this new function. We provide it a value for the score. In this example, I'll use a value of 85. We run this and see the value of B, which is correct. What about a different value? We use an input of 62 and run the function. We see an output of D. So that's how the function works. Let's update our main query. Inside the CTE, we remove that subquery and add the call to the function. We provide a value of the score 1 from the enrollment table. We don't need to look up the value from the normalized table. We'll give this an alias of grade score 1. Then we can copy and paste this for each score to use and modify the parameter and the column alias. In the main outer query, we can select each of the 10 grade score values. Our query is now ready. We can run it and see our results here. We have 25 rows and all of our grade scores here. What else can we do to clean up this query? One area that has a case statement is this course category logic here. It has a case statement which is okay, but could be an area for improvement. It has a like keyword which looks for the first 2 characters of the course code and returns a value based on that. Ideally, instead of looking at a wildcard match on the course code like this, we would have a list of course codes and a corresponding category. We can create a lookup table that does this. It means the logic is driven by the data and not by the code. How can we do this? We start by creating a table. We'll call it course category. It will store the code and the category name to return. Now, ideally, we would normalize this. By that, I mean we would add a category ID to the course table and then look up the ID. You can do that and you'll probably end up with a better design. But we could assume for this exercise that we can't modify the base table. Sometimes we can't do that in a real scenario. So we create this table. Then we insert some data. How do we know what to insert? We need a list of course codes. We can write a simple select distinct query here to get the unique values. We run this and see our results. So we can insert records for these values into our table. I'll add this insert statement here, which uses the same logic as our case statement to determine the course category. We run this and the data is inserted. Let's update our main query. We do a left join to the course category table. Then we select the category name from our new course category table. That's all we need to do. We run the query and see our results here. We see the category name values, which are the same as before. We've got our final query here on one side, and we have the original query here on the other side. We've done a lot to this query to make it better. We moved the reusable logic to a function, we moved a lot of the enrollment calculations to a CTE, and even tried a few other things which didn't quite work out. What else could you do? You could move the calculations for attendance and the final score to a function, but they are only used once in this query, so it may not be worth the effort. You can also investigate the performance of this query to see where the bottlenecks are to help restructure the query or add indexes. Writing SQL is all about solving problems and getting answers from our data. You'll want to watch this video next, where I walk through my 5-step process for writing an SQL query to solve the problem you want to solve. Thanks for watching.